Let us look at what? The next subtopic under chemical bonding, which is covalent bond. So this covalent bond is a kind of bond that involves the sharing of what? Of electron. This is involve the what? Sharing of what? Of electron between covalent bond the what? Sharing of electron between two elements or two atoms of the same element or two what? Atom of different elements. And the covalent bond is always denoted by short what? Short bar. Don't forget, and it also occurs between two nonmetals. The main properties of this bond is what? It involves sharing of what? Of electron. Involve what? Sharing of what? Of electron between two what? Two atoms of the same element or of different elements. And it occurs between what? Two what? Two what? Two nonmetals. Where the first one, ionic bond, is involving what? Transfer of electron from metal to nonmetals. But here, it occurs between two nonmetals and they share the what? Electron. Look at it now. If we have A with this electron, want to react with what? B with this electron. Let me say A react with what? With B. And electron in what? In A is dot. Electron in B is what? Is X. If the two now react together, what are we going to have there? They will share the what? Electron. There's nothing like transfer here. This is A and this is what? B. So between them, we have what? Electron of A as dot and electron of B as what? As X. They share it, and this structure, we can also write it in this form, or we can also write it in this form. It will be what? A and what? And B. But I said the sharing of electron, we can use what? Short bar to represent what? Covalent bond. So we can put what? Short bar here. This bond you see between them is what? Is represent the sharing of what? Of electron, which is what? We have dot here and we have what? This what? X here. We can now see that what? For covalent bond, when they share electron, we use short bar to represent it. And in the short bar, we have how many electrons there? One pair of electrons, which is what? Two electrons, Abi. So let us look at what? The formation of what? Of covalent what? Covalent bond. Formation of covalent bond. So if I look at formation of covalent bond, the first element that I would like to treat, let me treat what? Eh? Yes. Let me try this first. Formation of HCl. So look at it now. If you have H here, react with what? Chlorine to form H what? Cl. Let us look at what? The formation that happened there. This one is atomic number 1. We have 1. This one is 17, which is what? 2, 8, 7. Abi? Abi now? So if they want to what? The bond together. Let me draw the stuff like this. Assume this hydrogen is what? Is this. This chlorine is what? Is this. Permit me, I will just write what? Their electronic configuration alone. Here we have H, Cl. So for hydrogen, I will write what? 1 here, electron. For the chlorine, permit me to what? To write what? The atom share electron alone, which is what? 7. So for chlorine, I will write 7 here, which is what? 1, 2, 3, 4, 5, 6. Yay! I don't like it in that way. Let me use what? This 2, E to represent the electron. E. Yes, we have E. So if the two now what? React together, it will give us what? So they will overlap, they will share the what? Electron. So when they share the what? Electron, we have this is hydrogen, this is what? Chlorine. The electron of hydrogen, I use what? X to denote it. This is X electron by hydrogen. Electron of what? Of chlorine, I'm using black marker to denote it, which is what? E of chlorine. We have 1 here, 2 here, 3, 4, 5, 6. Abi, this is hydrogen. This is what? Chlorine. Can you see this structure now? I can now what? Draw it here. Or this is H. The bond between them here is this. This is what? Chlorine. Abi, the electron I put here on top of chlorine here is this. I can now use what? This electron dot to represent it 2 here, 2 here, 2 here. We have 6 pairs of electron or 3 pairs of electron here. This is level structure of it. So this bond now it contains how many electrons there? Don't forget, 1 is X, 1 is what? Is E. This is what? How chlorine what? Over what? HCl overlap. The second one, let me look at what? Formation of fluorine molecule. If you look at fluorine molecule, here, fluorine molecule is a combination of what? Let me put it here. It's a combination of what? Of FH plus F to give us what? Hydrogen fluoride. Sorry, F2. We have fluorine plus fluorine to give us what? F2. What do we have there? 2, 7. Abi? Here we also have two what? Two 7. Now let us draw the what? The valency what? Share. Draw the valency share here. We have, sorry, this one, we have what? Fluorine. Our electron. 1, 2, 3, 4, 5, 6, 7. The second fluorine, let me use black marker for it. The second fluorine, we have what? F. 1, 2, 3, 4, 5, 6, 7. They will now react together. So when they react together, it will give us what? This. They will overlap. So when they overlap, the first fluorine is what? Is F. The second one is what? Is F here. So X here 1, 2, 3, 4, 5, 6. Here we have what? E. 1, 2, 3, 4, 5, 6. Then this one pair. Put it here. You cannot draw this structure here. Or fluorine bond with what? With F. So in this one now, we have how many electrons here? 1, 2, 3, 4, 5, 6. Here encore, we have what? We have 1, 2, 3, 4, 5, 6. Abi? So what I would like to establish something here. Now, just two electrons are participate in what? In bonds. The remaining one, they are not involved in what? In bonding. Abi? So note, NB, any electron that is what? Electron that evolve in what? Evolve in what? In bonding are called bond electron. Are called what? Bond electron. Here we have how many bond electron here? 1. How many bond electron we have here? Bond electron, or we call it what? Bond pair. Or we call it what? Bond pair. Bond what? Pair. Please note it. But all these electrons here, which are not participating what? In bonding, we call them what? Lone pair. Lone what? Pair. Any electron which does not involve in bonding are called what? Lone pair. In this structure now, the lone pair here are these 1, 2, 3. Those are the what? Lone what? Lone pair. They are not involved in bonding. But the one that you have in the middle here, which is involved in bonding, we call them what? Bond what? Bond pair. Please note it. So in this fluorine now, molecule, we have 6 what? Lone pair. 1, 2, 3, 4, 5, 6. But we have how many bond pair? 1. Any electron that involved in bonding are called bond pair. The one that involved in bonding are called what? Lone what? Lone pair. So the third example is what? Formation of oxygen. If we look at formation of oxygen, we have O react with another O to give us what? O2. This one is 8686. By drawing the configuration of oxygen, we have 1, 2, 3, 4, 5, 6. Oxygen, atomos shell. For the second one too, we have what? 1, 1, 2, 3, 4, 5, 6. So if they now react together, they will share the electron. So this one will share with what? With this. This will share with what? With this. So by sharing, we have what? This kind of what? Of structure like this. This one share with this, we have Xe. This share with this, we have what? Xe. This one that is our remaining here. Which one what? 1 here. 1, 2, 1, 2. This one that remaining here. 1, 2, 1, 2. Abi, let us draw it now. Mhm. Yeah, if you draw the diagram here, or oh, how many electrons are involved in body here? 4 electrons, Abi, which is 2 pair. This 2 here represent this bond. This one represents what? This bond. So this is bond pair. Here we have what? 1, 2, 1, 2. Here we have 1, 2, 1, 2. This is level structure for what? For oxygen molecule. So the bond I think between 2 oxygen is what? Is double bond. So the next one is what? Formation of nitrogen. So in this oxygen now, we have how many bond pair? 2 bond pair. How many lone pair? We have 8 lone pair. Formation of nitrogen what? Molecule. Oxygen what? Molecule. Fluorine mo what? Molecule. HCl gas. So in this side now of nitrogen, we will have what? Nitrogen react with nitrogen to give you what? N2 gas. So if you have it in this form, nitrogen is what? 2, 5. This is also what? 2, 5. So by drawing the what? The configuration for nitrogen plus this, another nitrogen. So put 5 outside Abi. We have 1, 2 here, 1 here, 1 here, 1 here, 1 here. For this one, we have 1, 2, we have what? 1 here, 1 here, 1 here. If they now combine together, what are we going to have? They will overlap. So is if they overlap, the one this if they overlap, this one will bond with this one will share with this one will share with this. If you look at it now, what are we going to have? We have Xe, the second one, another Xe, the third one, Xe. So what left here? We have what? 1, 2. The second one, 2. We have E. If you are now drawn to what? Asked to draw the nitrogen gas we have here, you have what? N. And between the nitrogen, we have how many bonds? 3. 1, 2, 3. Here, put what? X here. Put what? Dot here. So in nitrogen molecule, we have 3 bond pair and we have 2 lone what? Lone pair. This is how what? How am I going to put it? The covalent compound is what? Is being formed. Covalent compound just deal with what? The overlapping of what? Of 2 or more electron. So it is occur between what? 2 non-metals. Let us look at what? The properties of what? Of covalent compound. Number 1, see, look at the covalent compound. At room temperature, the covalent compound are usually gas and liquid. At what? At room temperature. The covalent compound, they are what? Are gas and what? Liquid. Note that at ordinary temperature, the ionic compounds are what? Solid. But the covalent compound at ordinary room temperature, they is in what? In gaseous state or in what? In liquid state. And two, covalent compound, they are soluble, which is what? They are dissolved in non-polar solvents. They are what? They are soluble in what? In non-polar solvent, like benzene. But they are what? Insoluble in polar solvents, like what? Like water. But if it's ionic compound, they will dissolve in what? Polar solvents because of the what of the charge they have. Their charge will attract each other and they repel each other. So they are insoluble in they are insoluble in what? In polar solvents, like what? Like water. And they are what? They are what? Electrolytes. You know that what? Ionic bonds, when they are in a multi form, they are electrolytes. They allow the passage of the what? Of electricity when in their what? They are in solution. Those are the what? The basic properties of what? Of covalent what? Covalent compound. So the next thing that we are going to treat under covalent compound is what? Classification of covalent molecule. What? Classification of what? Covalent what? Molecule. Covalent molecule. Molecule. So the covalent molecule can be classified into what? Into two parts. We have what we call what? Polar molecule. This polar molecule, they are bound together by what? By what we call polar bond. And the second one we have what? Non what? Non-polar what? Molecule. They are bound together by what? Non-polar what? Non-polar bond. Let us take it one after the what? The other. The first one is what? Polar what? Molecule or polar what? Polar bond. What is polar bond? Or what is polar what? Molecule. Polar molecule can be defined as a molecule that is comprised of two or more atoms of different electronegativity. Is a molecule that is contained or comprised of two atoms or two or more atoms of different electronegativity. And the bond in polar molecule is called polar bond. So polar bond is a bond that is exists between two atoms of different electronegativity, and their bond electron will shift towards the what? Element of higher negativity. Look at it now. If you are talking of what? Polar molecule, we have the example is what? H what? HCl. Look at H what? HCl. We have hydrogen and we have what? Chlorine here. So the two elements of different what? Negativity. You know, I said it here before that what? This is their bond electron can be found in what? In between the two elements. Abi? Good. Since the bond electron can be found what? Is in between. But in terms of electronegativity, you know that what? What? Negativity. Please, you need to go and check your what? Your periodic table. Check my videos under periodicity and external electronegativity. Electronegativity is what? What is the meaning of electronegativity? Is the tendency of an element to attract electron toward his what? Toward itself. And this chlorine is more electronegative than what? The hydrogen. Therefore, this bond electron we have here, this is supposed to be at what? At the middle. Because of electronegativity power of what? Of this chlorine, it will now what? Shift the what? The bond electron toward is what? Toward itself. This is the bond electron. It will now move toward the what? The chlorine. When the bond electron move toward the chlorine, this chlorine will now behave partial negative. This one now behave what? Partial positive. What caused this what? The charge on this chlorine? Because is what? Is withdraw, attract, shift the what? This bond electron toward itself, and then this one that is lack electron partially will become partial what? Positive. So this kind of molecule are called polar molecule. And the bond here is called polar bond. Whenever this kind of molecule is dissolved in what? In water, it's what? They will, you know, the molecule is react with water, they will dissolve because they have what? They have charge. That is what we call what? Polar what? Polar molecule. Any molecule that is have what? The molecule that is combined of two or more atoms of different electronegativity. That is what we call what? Polar molecule. So that's it. Or we can also hear me use what? This as case of study again. We can use water too. If you look at water, we have H here. This is the bond, Abi. And this one is oxygen. And we have what we call what? Lone pair here. Lone pair here. Let me use blue marker. We have lone what? Lone pair here and lone pair what? And I've said it before earlier that we use space short bar to represent what? Covalent bond. Abi? So, and I said in each what? Bond, we have two electrons. So we have two electrons here, two electrons here. But oxygen is more powerful in terms of electronegativity than hydrogen. And the bond electron here will shift to what? To this side. The bond electron will shift to this side. In other words, we shift what? To this side. So the electron shifts here, electron will shift here. So as a result of that, this one will become partial positive because it's loose electron. This one will also become what? Partial positive. And this oxygen here, it will become what? Partial what? Negative. Because it's the one that is of have what? Ability to what? To attract electron to its what? To itself. You can now see that what? This water, it has what? Charge. That's why water is also called what? Polar molecule. The next one I said was is non-polar what? Molecule. The for non-polar what? Molecule. If you said molecule is what? Non what? Non-polar molecule or non-polar what? Bond. So I said what? The bond in a non-polar molecule is called what? Non-polar bond. If let me use this as a case of study, which is what? Fluorine. Look at what? Fluorine here. We have fluorine molecule, which is, or let me use fluorine molecule, Cl, Cl. So you can see that what? I forgot something here. I'm supposed to put what? One arrow here. This arrow tells that what? The bond electron shifts sent to the what? To the chlorine. So we have chlorine molecule now. Abi, in a non-polar molecule is a molecule that is comprised of what? Of two or more elements of the same electronegativity. This one, two elements of different electronegativity. This one, two elements of the same kind, of the same electro what? Negativity. So if the two of them have the same electro what? Electronegativity, how are we going to determine the same electronegativity? And their bond electron can be what? Can be found here. The bond electron is still at what? At the middle. Is what? Is equally what? Distributed. But the bond electron here is evenly what? Distributed, shift to one side. But here, the electron bond electron will stay at what? At the middle, because they have the same electron what? Negativity. So this kind of what? Of bond is called what? Non-polar molecule. And then we can also look at what? This bond, the bond we have in what? Between two hydrogen atom. Two. Here, the electron will what? Will stay at the what? At the middle, because they are elements of the same what? Electronegativity. So this is what? Non-polar molecule, and the bond in them is what? Is non-polar bond. But how are we going to what? To determine whether an element is what? Is a polar or non-polar molecule. How are we going to determine whether a compound or a solvent or a gas is a polar or non-polar solvent? Or how are we going to determine that what? A molecule is a polar or not polar? So the answer for that is what? Is two things that we can use to determine the what? The polarity. The what? Polarity. Polarity of what? Of molecule can be determined by two things. The first one is what? What we call what? Dipole what? Moment. The second one is by using what? Electronegativity. So we have know the difference between polar and non-polar molecule. Now, polar molecule or polar bond is a bond that exists between two elements of different electronegativity. Polar, non-polar bond is what? Is a molecule. Non-polar molecule is a molecule with difference, with the same electronegativity. Non-polar, the same. Polar, different electronegativity. Water and HCl are non-polar bonds. Chlorine molecule, hydrogen molecule, fluorine molecule, oxygen molecule, they are what? They are not polar molecule. We will apply all these polar molecule and not polar molecule in intramolecular force when we get to the what we call the what? Van der Waals force, London dispersion force, dipole attraction. Please, that's why I'm trying to write it very well. Polar bonds or molecule with different electronegativity. Non-polar, a molecule with the same electronegativity elements. So how are we going to determine the polarity of a molecule now? So I said what? We can determine the polarity of a molecule by what? Dipole moment or electronegativity of the element. So this now leads us to the what we call what? Dipole moment and electronegativity.